This is the lesson activity for lesson number 7 for college algebra. Solve the following quadratic equations. So for number 1, because there's no x term, I'm going to use the square root property. So I'm going to square root both sides. The square root of x squared is the absolute value of x. The square root of 49 is 7. So it has to be that x is plus or minus 7. 2x squared minus 6x plus 4. Factoring when you have a coefficient of 2 is always a little bit trickier because you can't use that find a number that multiplies to this but adds to this trick. So you have to do a little bit more guess and check. And I'm not even sure if it's going to factor, but I'm going to try it. I'm going to put 2x and x. And then these two numbers would have to multiply to 4. And when I FOIL, I have to get the negative 6x. So I have 2x times something plus x times something to give me negative 6x. All right, so what happens if I just put 2's in here? Like 2 and 2. When I multiply, I get 2x squared. Then I get 4x and 2x. So that's promising. 4x and 2x add to 6x. So I'm going to make them both negative. And then it'll add to negative 6x, but it will still multiply to negative 4, to positive 4, because negative 2 times negative 2 is positive 4. So this factors, that's nice. And then I can set each factor equal to 0 because of the zero product property. So either 2x minus 2 is 0, or x minus 2 is 0. Here I get x equals 1, and here I get x equals 2. Number 2, 5x squared equals 20x minus 6. This is a quadratic, so I want to start by making one side 0. Number 2, 5x squared equals 20x minus 6. First instinct with a quadratic is that we should be making one side 0. So I'm going to move everything to the left side, and I have 5x squared minus 20x plus 6 equals 0. So I subtracted 20x and I added 6 to both sides. And then I could try to factor. Whenever you have a coefficient that is not 1, like we did up here, sometimes if you're not confident that it's going to factor, you might jump straight to the quadratic formula, and that's what I'm going to do now. So I have x equals negative b, so that would be 20, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And that simplifies to 20 plus or minus the square root of 400 minus 120. 400 minus 120 is 280. All over 10. And then I have to decide if 280 has any perfect square factors. And I believe that the only one is 4. So I'm going to rewrite this as 20 plus or minus the square root of 4 times 70. All over 10. And then take the square root of the 4. So I have 20 plus or minus 2 square root 70 over 10. Break it into two fractions, 20 over 10 plus or minus 2 root 70 over 10, and reduce each of the fractions. So I have 2 plus or minus root 70 over 5. So that is my exact answer written as a reduced radical because that's what the directions asked for. And then next, I'm just going to type this into my calculator and get a decimal. So 2 decimals actually, one for the plus, one for the minus. So I just typed this into my calculator and I got 3.67 when I did the plus, 2 plus root 70 over 5. And when I did the minus, 2 minus root 70 over 5, I got 0.33. Number 3, x squared plus x equals 0. I could use the quadratic formula and make my c value 0. But because there's no c term, there's no constant term, every term has at least one x in it. So I can factor out an x, and I have x plus 1 equals 0. And then I can use the zero product property. So either x equals 0 or x plus 1 equals 0. And that one's done. And this one I get x equals -1. Number 4. So I have a couple of options here. I could square the x minus 7 by multiplying it out. X minus 7 times x minus 7. Distribute the -2. I could make this look like standard form, ax squared plus bx plus c equals 0. But because I have some stuff squared, I'm going to try to use the square root property, square rooting both sides option. So I'm going to start by dividing both sides by -2 to get the squared stuff alone. So I have x minus 7 squared equals 10. And then I can square root both sides. And we know that the square root of x squared is the absolute value of x. That's true for any kind of stuff. The square root of some stuff squared is the absolute value of the stuff. Square root of 10 is not a perfect square, so I'm just going to leave it as square root 10. And then, remember, when you have an absolute value equation, the stuff could be the number, or the stuff could be the negative of the number. And then I'm just going to add 7 to both sides. So x is 7 plus root 10, or x is 7 minus root 10. Number 5, we want to solve a polynomial equation. Warning, we do not want to divide both sides by an unknown, because one thing that you never can do is divide by 0. And we don't know what x is yet, so we don't want to divide by it. We might accidentally divide by 0. So what I'm going to do instead is gather all the terms on one side of the equation. So I'm going to subtract 6x squared from both sides. So I have x to the 4th plus x cubed minus 6x squared equals 0, and hope that I can factor this and use the zero product property. So every term has at least 2 factors of x in it. So I'm going to factor out an x squared. I have x squared plus x minus 6 left when I do that. And then x squared plus x minus 6, I'm going to hope that that factors further, because my only hope to solve this is the zero product property. So the coefficient on the x squared is a 1, which means I just need 2 numbers that multiply to -6 but add to +1. So I'm thinking +3 and -2. And then I have 3 factors multiplied together. The answer is 0. So 1 or more of these factors must be 0. And I get x equals 0, x equals -3, or x equals 2. Number 6, we're going to solve an absolute value equation. So my first step is to isolate the absolute value. I just want to have the absolute value of some stuff equals a number. So I'm going to add 4 to both sides. So I'm just treating the absolute value as though it were an x, right? Get it by itself. So 29 plus 4, that's 33. Then I'm going to divide both sides by 3. So my absolute value of 2x minus 5 equals 11. And then if the absolute value of something is 11, that something could be 11, or it could be -11. Either way, its absolute value will be 11. So I break this into 2 separate equations, lose the absolute value bars, and then I'm going to add 5 to both sides. I get 16 here, divide by 2, and I get 8. So x equals 8 is one equation, and then over here, add 5 to both sides. -11 plus 5 is -6. Divide both sides by 2, and I get x equals -3. Number 7 is optional extra practice. So if you feel confident moving on to the next lesson, feel free to do that. Part A, I have a cubic, which means it's not quadratic. I can't use a quadratic formula, so I'm going to try to factor. So every term has at least one factor of an x in it. So I'm going to pull out an x, and I get x squared minus 3x minus 4. And then that, I believe, will factor. So I have x, and I'm going to have a double bubble. Okay, I'm going to put an x and an x. And then what I put here and here are two numbers that are going to multiply to -4, but add to -3. So I think -4 and +1 will do that. And then I set each factor equal to 0. So I get x equals 0, or x minus 4 equals 0, or x plus 1 equals 0. That's solved. And here I get x equals 4. And here I get x equals -1. Part B, x cubed equals 16x. Very tempting to divide both sides by 16, but we always try to avoid dividing by an unknown because that unknown might be 0 and we would create a black hole or something. So instead, I'm going to move the 16x to the left. I'm going to subtract 16x from both sides so that I have x cubed minus 16x equals 0, and then I'll factor that x out. So every term has at least an x factor in it, and I have x squared minus 16 left, and that's a difference of two squares, so that factors. So I'm going to have x times x plus 4, x minus 4. Set each of those three factors equal to 0 and solve, and we get x equals 0, -4, and 4. Part C, 4x squared plus 12x plus 9. We could certainly try to factor it, but when you have and it equals 0, when you have a coefficient that's not 1, factoring is typically harder. And if you're not sure that it's going to factor, you might decide not to waste your time trying and jump right to the quadratic formula. So I think that's what I'm going to do, and I'm going to have x equals -b plus or minus the square root of b squared, so 12 squared is 144, minus 4 times a times c, all over 2 times a. And that will simplify to -12 plus or minus the square root of 144 minus 4 times 4 times 9. Pop that in a calculator if you don't know, and it is 144. All over 8. And then 144 minus 144 is 0. The square root of 0 is 0. So this is just -12 over 8, which would reduce to, divide top and bottom by 4, -3 over 2. And our last problem for practice is an absolute value. I want to isolate the absolute value first, so I'm going to subtract 4 from both sides, and I get the absolute value of 6x minus 2 equals 28. And if the absolute value of some stuff is 28, then either that stuff is 28, or that stuff is -28. And now I have two separate equations to solve. So 6x minus 2 equals 28. Add 2 to both sides, and I get 6x equals 30. Divide by 6, so I get x equals 5. There's one solution. And then 6x minus 2 is -28, so I'm going to add 2 to both sides, and I get 6x equals -28 plus 2 is -26. Divide both sides by 6, and I get x equals -26 over 6. That's a little annoying. It reduces to -13 over 3.